High-efficiency in-floor heating systems offer several options. Firstly, consider hydronic heating. This system uses hot water circulating through pipes embedded in the flooring. Hydronic systems offer high thermal conductivity and even heat distribution. They are energy efficient, with low operating costs and high comfort levels. Secondly, there's electric heating. This utilizes electrical resistance to generate heat. Electric systems have lower upfront costs than hydronic systems. They can be zone controlled for greater energy efficiency. Thirdly, radiant heating is a good option. Radiant heating emits infrared radiation that warms objects and people directly. It is highly energy efficient as heat is directed upwards, providing gentle, comfortable warmth. Fourthly, heat pumps are a possibility. Heat pumps extract heat from the ground or air and transfer it to the flooring. They offer exceptional energy efficiency, especially in moderate climates. Heat pumps can provide both heating and cooling, reducing equipment costs. Fifthly, geothermal heating could be utilized. Geothermal heating utilizes the Earth's stable temperatures to generate heat. It is extremely energy efficient and environmentally friendly. It requires specialized equipment and significant upfront investment. When considering high efficiency, several additional factors are important. Insulation is key. Ensure adequate insulation below the flooring to minimize heat loss. Floor coverings play a role. Choose wall coverings with high thermal conductivity to optimize heat transfer. Zone control is beneficial. Divide the heating system into zones to control temperatures individually, reducing energy waste. Smart thermostats are valuable. Install programmable or smart thermostats to optimize heating schedules and reduce energy consumption. When selecting floor coverings for radiant floor heating, consider materials with high thermal conductivity. Tile and stone are excellent choices as they efficiently transfer heat into the room. Engineered wood is another option, but it's crucial to select a product specifically designed for radiant heat to prevent warping or damage. Carpeting can impede heat transfer and reduce efficiency, so it's generally not recommended. If you choose carpet, opt for low-pile options with minimal padding to maximize heat output. Also, consider the R value of the flooring material, which indicates its resistance to heat flow. Lower R values are preferable for radiant floor heating systems. When discussing the thermostat, it's essential to understand the different types available. Programmable thermostats allow you to set specific heating schedules based on time of day and day of the week, ensuring that the system only operates when needed. Smart thermostats take this a step further by learning your heating preferences and automatically adjusting the schedule to optimize energy savings. Some smart thermostats can also be controlled remotely via a smartphone app, allowing you to adjust the temperature even when you're away from home. These thermostats often integrate with other smart home devices, such as occupancy sensors, to further enhance energy efficiency. For example, the system can automatically lower the temperature when no one is in the room. When insulating beneath a radiant floor heating system, it's important to use materials that can withstand the temperatures and moisture levels involved. Rigid foam insulation, such as expanded polystyrene, extruded polystyrene, or polycyanurate, is commonly used due to its high R value and resistance to moisture. The thickness of the insulation will depend on several factors, including the climate, the type of flooring, and the desired level of energy efficiency. In colder climates, thicker insulation is generally recommended to minimize heat loss. It's also important to ensure that the insulation is properly installed to prevent gaps or air leaks, which can significantly reduce its effectiveness. Vapor barriers may also be necessary in some applications to prevent moisture from damaging the insulation or subfloor. When designing a radiant floor heating system, it's crucial to calculate the appropriate heat output to ensure that the space is adequately heated. This calculation takes into account several factors, including the size of the room, the insulation levels, the type of flooring, and the climate. Heat loss calculations are typically performed by a qualified HVAC professional using specialized software or industry-standard methods. The results of these calculations will determine the required water temperature and flow rate for hydronic systems, or the wattage per square foot for electric systems. Oversizing the system can lead to discomfort and energy waste, while undersizing can result in inadequate heating. When implementing zone control in a radiant floor heating system, it's essential to divide the space into distinct heating zones based on usage patterns and heat loss characteristics. For example, rooms with large windows or exterior walls may require more heat than interior rooms. Each zone is controlled by a separate thermostat that regulates the flow of hot water or electricity to that area. Zone control can be achieved using a variety of methods, including motorized valves for hydronic systems and individual electric heating mats or cables for electric systems. The thermostats can be wired directly to the heating system or connected wirelessly for greater flexibility. Implementing zone control can significantly improve energy efficiency by allowing you to heat only the areas that are in use. Considering the pipes used in hydronic radiant floor heating systems, cross-linked polyethylene or PEX is the most common choice due to its flexibility, durability, and resistance to high temperatures. PEX tubing is easy to install and can be bent around obstacles without the need for fittings, reducing the risk of leaks. Other materials, such as copper and polyethylene, or P, can also be used, but they are less common due to their higher cost or lower performance. The size of the tubing will depend on the heat output requirements of the system, with larger tubing generally providing better flow rates and lower pressure drops. It's also important to ensure that the tubing is compatible with the heating system components and that it is installed according to the manufacturer's instructions. When integrating a radiant floor heating system with renewable energy sources, such as solar thermal collectors or geothermal heat pumps, it's important to consider the system design and control strategies. Solar thermal collectors can be used to preheat the water used in hydronic systems, reducing the demand on conventional water heaters. Geothermal heat pumps can extract heat from the earth or air and transfer it to the flooring, providing a highly efficient and sustainable heating solution. In both cases, it's important to ensure that the renewable energy source is properly sized to meet the heating demand and that the system is designed to maximize energy savings. Control systems can be used to optimize the use of renewable energy and to switch to conventional heating sources when necessary. When discussing maintenance for radiant floor heating systems, hydronic systems typically require less maintenance than other types of heating systems. However, it's important to periodically inspect the system for leaks, corrosion, and other signs of damage. The water in the system should also be tested and treated to prevent the buildup of scale and other contaminants. Electric systems may require occasional inspection of the heating elements and wiring to ensure that they are in good condition. Smart thermostats can also be monitored for proper functioning and battery replacement. Regular maintenance can help to ensure that the system operates efficiently and reliably for many years. Thinking about the cost of radiant floor heating systems, the upfront cost of radiant floor heating can be higher than that of conventional heating systems, particularly for hydronic systems, due to the cost of the tubing, manifolds, and other components. Electric systems generally have lower upfront costs, but they may have higher operating costs due to the higher price of electricity. However, radiant floor heating systems can offer significant long-term cost savings due to their higher energy efficiency and low maintenance requirements. The payback period for a radiant floor heating system will depend on several factors, including the cost of energy, the climate, and the efficiency of the system. Exploring some design considerations for radiant floor heating, the design of a radiant floor heating system should take into account the layout of the space, the insulation levels, the type of flooring, and the climate. The tubing or heating element should be spaced evenly throughout the floor to provide uniform heat distribution. Areas with high heat loss, such as near windows or exterior walls, may require closer spacing. The system should also be designed to prevent overheating, particularly in areas with direct sunlight. A qualified HVAC professional can help to ensure that the system is properly designed and installed. When considering comfort levels associated with radiant floor heating provides a comfortable and even heat distribution throughout the space. Unlike forced air systems, which can create drafts and hotspots, radiant floor heating warms the objects and surfaces in the room directly, creating a more consistent and comfortable temperature. Radiant floor heating can also help to reduce dust and allergens in the air, as it does not circulate air in the same way as forced air systems. Many people find that radiant floor heating provides a more pleasant and comfortable heating experience than other types of heating systems. Regarding the building codes that might come into play, radiant floor heating systems must comply with all applicable building codes and regulations. These codes may address issues such as energy efficiency, safety, and accessibility. It's important to ensure that the system is designed and installed in accordance with these codes to prevent problems and ensure that the system is safe and reliable. A qualified HVAC professional can help to ensure that the system meets all applicable codes and regulations. Considering the environmental benefits, radiant floor heating can offer several environmental benefits compared to conventional heating systems. Radiant floor heating is more energy efficient, reducing greenhouse gas emissions and conserving resources. Radiant floor heating can also be integrated with renewable energy sources, such as solar thermal collectors and geothermal heat pumps, further reducing its environmental impact. The combination of energy efficiency and renewable energy integration makes radiant floor heating a sustainable and environmentally friendly heating solution. Another point about the life expectancy of radiant floor heating systems. Radiant floor heating systems can have a long life expectancy if they are properly designed, installed, and maintained. Hydronic systems can last for many decades, with some systems lasting for 50 years or more. Electric systems may have a shorter life expectancy, but they can still last for 20 years or more. Regular maintenance can help to extend the life expectancy of the system and ensure that it operates efficiently. When we think about some troubleshooting for radiant floor heating systems, common problems with radiant floor heating systems include leaks, airlocks, and thermostat malfunctions. Leaks can be caused by corrosion, damage, or improper installation. Airlocks can prevent the water from circulating properly in hydronic systems. Thermostat malfunctions can prevent the system from turning on or off, or from maintaining the desired temperature. A qualified HVAC professional can help to diagnose and repair these problems. When discussing the topic of expansion joints are necessary in radiant floor heating systems to accommodate the expansion and contraction of the flooring materials due to temperature changes. Expansion joints are typically installed at regular intervals throughout the floor and around the perimeter of the room. They can also be installed around doorways and other openings. The type and size of the expansion joints will depend on the type of flooring material and the size of the space. If expansion joints are not properly installed, the flooring can crack or buckle. You can think about the thermal mass effect also. Thermal mass refers to the ability of a material to store heat. Materials with high thermal mass, such as concrete and stone, can store a large amount of heat and release it slowly over time. This can help to stabilize the temperature in a room and reduce energy consumption. Radiant floor heating systems are often installed in conjunction with materials with high thermal mass to maximize their energy efficiency. When discussing moisture control is important in radiant floor heating systems to prevent damage to the flooring materials and to prevent the growth of mold and mildew. Vapor barriers can be installed under the flooring to prevent moisture from migrating into the floor. Proper ventilation can also help to control moisture levels in the room. If moisture problems are not addressed, they can lead to costly repairs. And let us not forget about snow melting applications of floor heating. Radiant floor heating systems can also be used for snow melting applications. Heating cables or tubing can be embedded in driveways, sidewalks, and patios to melt snow and ice. This can help to prevent accidents and injuries, and it can also eliminate the need for snow removal. Snow melting systems can be controlled manually or automatically using sensors that detect snow and ice. There is also the topic of how radiant cooling works within floor systems. Radiant floor heating systems can also be used for radiant cooling. In this case, chilled water is circulated through the tubing in the floor to absorb heat from the room. Radiant cooling can provide a comfortable and energy-efficient alternative to air conditioning. However, it's important to control humidity levels in the room to prevent condensation from forming on the floor. Radiant cooling is most effective in climates with low humidity. Regarding the topic of embedded sensors and controls can be used to optimize the performance of radiant floor heating systems. Sensors can be used to monitor the temperature of the floor, the air, and the water. This information can be used to adjust the heating system to maintain the desired temperature and to prevent overheating. Controls can also be used to optimize the use of renewable energy sources and to switch to conventional heating sources when necessary. Then there is the topic of building management systems, or BMS. Radiant floor heating systems can be integrated with building management systems to provide centralized control and monitoring of the heating system. Building management systems can be used to optimize energy consumption, to monitor system performance, and to provide alerts in case of problems. Building management systems can also be used to integrate the radiant floor heating system with other building systems such as lighting and security.